Okay. Hi, everyone. So as you all know, this meeting is recorded and will be uploaded to YouTube. So I guess I'm going to start with the items we have on the list. I have two quick items on my side. So for the first one, just a reminder for the release schedule for 1.17. This is going to be shorter than the previous cycles because of the holidays. Mid-next month, like within a month, October 15th, enhancement freeze. And then a month after that, November 14th, we will have the code freeze. So if you're working on a feature that will require enhancement freeze, please submit it as soon as you can. Looking at the list of tasks that we have planned for 117, I don't think we have any other than Aldo's topology spreading, and I might have something for the framework migration. For the framework migration, it's not going to be strictly like an alpha beta GA feature. It's mostly restructuring and refactoring, internal refactoring. We will not be introducing new APIs. And so it's less critical. But if Aldo is planning to have to work on the default spreading API and have it in 117 as alpha, then I think we should have an enhancement submitted before October 15th.
Sounds good.
Okay. Does anyone else have any questions about the new deadline?
Sorry, I didn't get that. What's the Alda's feature working on? The spreading?
It's the default topology spreading.
Okay, I see.
So it's basically providing a new API in the component config to allow specifying a default value for topology keys for default spreading. Right now it's fixed for zone. But if you want to make it configurable, then we should have something in component config to allow users to specify or administrators to specify the default spreading topology. Okay, so the second item, and again, this is going to be fairly quick. So I put up the migration plan initial thoughts. Thank you everybody for commenting. I started to work on some scaffolding, I would call them PRs, that will allow me to create PRs that others can address in parallel. And what I'm trying to do right now is to figure out the how the configuration would work out, and basically the dependencies that we have. We have two dependencies. The configuration API is one dependency. So we have the policy and the component config. You're just trying to figure out a way to merge those. And the other one is kubelet and a couple other components that actually call our predicates directly. So this is less critical. The first one is the most critical one. I started working on a PR to identify that, and then once that one is done, I think the picture will be a lot more clear, and we can do incremental migration of priorities and predicates into plugins. Does anyone have any questions related to the document that I shared that would like to discuss now? Okay, sounds good. So Vinay, take it away with your in-place point vertical scaling kit.
Yeah, hi. So this is just a follow-up from last week. The two items, one was to see if there are any concerns. I know that Klaus had some comments, I responded to them, and I was wondering if there are any open concerns at this point. The one comment that was regarding how to handle race condition during resize. So we looked at potentially you could use the max of resources and resources allocated for requests and the status resources limits for the limits. However, at the point of admission, we can we don't expect this to be like a long outage. There can be temporary situation where when the memory is being reduced uh, or a CPU is being reduced, that particular node on which the pod whose CPU or memory is being reduced is offline, then overall there might be a slight cluster resource oversubscription, but this shouldn't be a common thing. In any case, I talked about this with Signode on Tuesday, and if this does become a problem, it's a few lines of code change to fix it. So we figured we'll go with the simple approach for now. We'll use the resources, and as it is currently done, we'll just use it. It's just going to become mutable. For the limit ranger, I don't believe there is any issues. We have to just make sure that the min and max are respected, and we can either cap it at the min max levels, or we can reject the request if it is not compliant with the min max. Either approach is fine in the implementation detail. So I just wanted to ask if there are any concerns besides that from the scheduling side.
So I guess at the end of the day, I mean, whatever feature we go, whatever like solution we're going with, we need some like to experiment with it and have some data points on how common the different corner cases that you talked about occur. So I'm fine with what the KIP is proposing, and my hope is that during alpha we will get some feedback on how often these race conditions will happen and how would that actually impact the cluster in general. My hope is that we will have a solution that makes the cluster in a good state eventually, like basically eventual consistency. So it doesn't matter if we have a race condition at some point, but as long as, for example, the kubelet projects the pod, for example, and it gets evicted eventually, gets rescheduled somewhere else. I guess that's fine.
Okay, so the only other thing that I needed here in the KEP for API review, I need to mention approvers from each SIG that is going to be impacted by this KEP. So the three parts, SIG node is the biggest impact. SIG scheduling is a fairly small impact. And the auto scaling, which is a consumer, they all have almost zero impact, except one of the proposed policies is getting pushed to them. So I just wanted to know who can I list in the approvers list from Signode? Is it you or Klaus?
You can list either of us. Maybe Klaus, because he already commented on the KIP multiple times.
Oh, okay. All right. So I'll add Klaus as the approver and I'll update the KEP by Monday once I get confirmation from autoscaling as well and Signode.
Okay.
So I'll have Klaus as the approver.
Sounds good.
That's all I had. Thank you very much.
Thanks. So we have one more topic. Does anybody have any questions about Vinay's work on pod vertical scaling? Any concerns from other folks, contributors to this scheduler? Okay, so moving on to the next item, we have a discussion point on scheduling custom resources. I don't know who added that because it didn't post their name.
Hi, can you hear me?
Oh, yeah.
Yeah, I'm Ko Wang, and I want to discuss about the issue we proposed.
Okay, sounds good.
Okay, so what we want to do is add a custom resources scheduling for scheduler, which provides split policy and priority-based atomic scheduling for the CRD resources. We hope that users can describe the CRD resource as a whole, and Kubernetes schedules the CRD as a whole. And Then I want to introduce the background of this. Actually, many companies use Kubernetes as the underlying platform for their deep learning platforms. Deep learning job usually use GPU to train, and as the scale of the job increases, distributed training becomes inevitable, which a single training job must use multiple pods to host. However, users often only care about how many resources, the number of, to be exactly the number of the GPUs to use for a training job rather than the distribution of the backend. So at the same time, since the resources configuration and current usage of the cluster is unknown to users, there may be some problems when resource allocation is determined by user-defined pod group. So the first one is the unreasonable resource allocation. If the job is divided into multiple small grand pods, it will cause unnecessary interaction overhead between the pods. And the second is the job starvation. If the available resources of the cluster cannot satisfy the large grand job request, the job will not be scheduled for a long time, especially when small grand jobs or pods are scheduled. And the last problem may be resource deadlock. When some pods of a job are scheduled, the remaining pods cannot be scheduled, and the current occupied resources cannot be released. So the resource deadlock may happen. Mm-hmm. So in summary, we hope to implement the following functions. The first is the users only needs to describe the overall resource requirements of the CRD, and the cluster should automatically complete the splitting of the CRD to pods according to the total amount of resources and the current cluster resource usage. And the second is all pods belonging to a single CRD are scheduled automatically, which means all or nothing. That's all of our issue about.
Okay, so if I get that correctly, so you want to specify a new resource type. So you're describing it as custom resource of CRD, and you want to specify high-level resource requirements, whether that being CPU, memory, or number of GPUs. And then at scheduling time, we're going to just the scheduler should try to schedule that whole CRD on the cluster or on a specific node.
Actually, in the CRD, we describe the resource requirements of the CPU and GPU, and then the CRD is scheduled with the pods when putting into the scheduling list at first.
Right, so you're going to have to define an API to, for example, at runtime, decide how you're going to split that CRD into pods?
Yes, we want to introduce a split interface in the extender. So users can define their own splitters based on their own policies.
So at the end of the day, the scheduler is going to place pods on a specific nodes. What I want to understand is when you define a CRD, and let's call it a pod group rather than a CRD, because that's what it is. Am I correct? Like it's a group of pods.
Sorry?
It's a pod group, right? The CRD.
Yes.
So, and you want to define the total amount of resources for that pod group, but you don't want to specify how many pods.
Yes.
And what is the resources of each pod at the time you create that pod group, right?
Yes.
And you want the scheduler to basically, before you split that pod group into smaller pods, you want the scheduler to determine whether that whole pod group can be scheduled or not. Is that correct?
Sorry, could you repeat?
I'm trying to understand when you want this scheduler to call the API that you just mentioned to split that group into pods. Is that before or after we reserve the resources?
Before what?
So let's take a specific example. You create, let's call it the CRD that you talked about. It's called a pod group. Okay. In the pod group,
Yes.
the spec, you just specify the amount of resources that you want to allocate for that pod group, but you're not specifying the number of pods that this pod group splits to, right?
Yes, yes.
Okay, so the scheduler was, watching for that pod group, picked it up, and then what happens next? Do you want the scheduler to reserve resources and then call the split API to split the resources that we already reserved? Or you're
Yes,
going
yes.
to call the split and then you're gonna split into pods, and then the scheduler will just go ahead and schedule the pods normally as it's doing right now?
The pods that's splitted with the splitter, they will be binded by the extender that contains the splitter. Maybe I can explain more about our solution. May I?
Yeah, sure. Go ahead.
Yes. So first, based on our discussion before, we propose the following principles. First, we need the Kube scheduler to support the scheduling for CRD, but it does not need to understand the CRD, mainly because the diversity of CRD. And then the function that needs to understand the CRD is implemented by the user according to the characteristics of CRD. And the scheduler calls the function through the scheduler's extender mechanism. Which CRD needs to be scheduled depends on the configuration. And based on the above design principles, the preliminary concept of the systems is as below. First is the Kube scheduler. This part is a function extension to the default scheduler, mainly including first determining which CRDs need to be scheduled according to the configuration. And the second is implement the management of CRD and pods in the unified scheduling queue. And the third is cooperate with pod splitter to complete the atomic scheduling of CRD. And then we come to the pod splitter. Its main function is responsible to the scheduler's request. The splitter splits the CRD into pods according to the system resource configuration, current resource usage, and the user-defined CRD distributed strategy. Then it creates this pod and returns the results to scheduler. Yeah.
Can you give? I don't know if someone else has any questions. Please go ahead. I don't want to take all the bandwidth.
Well, I have one initial question, which is, why do we even need different different pods? Why can't this be created as a single pod with whatever number of containers you need?
Sorry.
So the question is, why creating a pod with multiple containers rather than multiple pods can solve this problem? So let me explain, try to explain again.
Yes, I can understand
okay.
your question. Maybe we'll think more about this. But for now, in TF jobs or something like this, they describe their jobs with pod more frequently. They describe this in many pods, right?
Okay, well, it's always an alternative to try if the pod is the scheduling unit. So if we can already fit our our workloads in this scaling unit, then we don't need any extra features.
So the idea is sometimes like large training jobs, you'll have to split it into multiple tasks, basically to do the training in parallel on different data points. So a pod is basically going to be usually a single process, or it's basically, even if it is multi-threaded, it's going to be confined to a single node. Or maybe if it is designed to use a single GPU, then you're out of luck of using multiple GPUs without splitting your training into multiple pods. So that's the motivation. And I think the question here is whether we can provide an API for co-scheduling. This is like one of the features that I guess QN is asking for. The other one is probably some sort of co-location, like you want to specify so that you address the starvation problem one of the problems that you had, right? Like you had.
There's already a cap for that, right? Or at least a cap in review?
For co-scheduling, yes. I'm just trying to address the issues that they're trying to solve. And then so that's the deadlock and non-optimal issue. It can be solved with co-scheduling, I believe. And I would like to understand from QN, if we forget about efficiency, would co-scheduling solve your problem?
Yes.
Okay, so at the higher level, what you're asking for is something like co-scheduling, but you want it to be more flexible. Basically, you don't want to specify the group of pods that you want to be co-scheduled ahead of time. You want it to be decided at runtime, and that's why you're proposing this split API.
Yes.
And the question is, why do you want it to be done at runtime? Why do you want to make the decision of how many pods needs to be created for a specific, what you call CRD? Why does that decision need to be at runtime?
Because when we divide the pod divide the CRD into pods, we want to know how the resources in the system, how many resources can be used. So that's basically what scheduler knows. So we want to insert the process in the process of the scheduler.
But I mean, you've already. Oh, okay, so basically what you're going to, but like the only thing that you're going to create an object, and that object is basically you're using just for the schedule to call you back, right? And the object contains the CRD that you mentioned, contains opaque data to the scheduler, so the scheduler has like really no knowledge of that. And but you still need from the scheduler some information, right? Like you need scheduler to pass to you some information so that you decide how many pods to create, right? At runtime. Basically, you want to know how much resources is left on the node, on the whole cluster. And
so it's based on the implementation of the extender. So different, not the user. Different companies may have their own solutions. So the scheduler just need to define the interface of the splitter of the extender.
Right, and I mean, to me, this looks like a second scheduler. I know that you discussed this in your issue, but I would like I would hope that like if you can create a like
yes, I think that there is an issue. We can read through all the background, then comment.
Yeah, exactly. You can create an like enhancement, maybe cap, so that we can comment on it. But I understand what you're trying to do, what you want to be done, I guess. I just want to make sure that we don't at all like have the means to do what you want to do, and that's why we have to have, for example, a new API.
Hi, I'm with her.
Mm-hmm.
I can explain this. Do you mean we should propose the KP in the community, and then you can comment our to give a evolution or something?
Yeah, we can comment.
I think we can go through the issue first to know what's the background and to see how we understand the problem and comment there first. And if we think it's fitable, then we will comment there, and yeah, you can then open the cap. Yeah.
Okay, I understand. So we still use the issue, right? And then if you agree, then we will keep keep our, right?
Yeah, sure.
Yeah, if we think it's feasible, then maybe you can submit a KIP with a more concrete, proposal of what the API would look like, etc. But we will take a look at the current issue and try to better understand how to solve your problem. And if there are no available solutions, we can discuss what you're proposing to add.
Okay. May I ask if there are some other solution or suggestion for these problems, like the resource efficiency, like we just mentioned before. Can you give us some advice or something?
If you're talking about resource efficiency as in co-location, or trying to, you can look at what the cluster autoscaler tries to do to make sure that it if you look at the scheduler, there are ways we can schedule pods. So there are priorities, and one of the priorities is to spread pods and use nodes that have lower utilization. And one of these priorities actually does the opposite. So basically it tries to prioritize nodes with higher utilization, so that you basically try to co-locate pods as much as possible, so that you don't spread your pods over a larger number of nodes. I don't know if that's the problem you're trying to solve. This is my understanding, at least from your description in the non-optimal example 2.
Okay.
So basically, like, if you have job number one took 4 GPUs on one of the nodes, and that node had, for example, 8 GPUs. So instead of if the next job comes in, or the next pod comes in and wants also another 4 GPUs, it will prioritize the node that already runs some pods, so that's already utilized.
Nice. Okay, we will think about it. May I ask if there is a plan or for the community to scheduling the custom resource, or it's all the pod based? And
There are no plans. It's the scheduler is the scheduling unit is pods.
What do you mean? Sorry.
You're asking if there are plans to schedule something else other than pods, and I'm saying no.
Oh, okay. I understand. Okay. That's it. We will talk about on the issues, and then we'll decide what to do for the next step.
Can you please share what one of these CRDs could look like so that we get a better picture?
It's just
I mean, in the issue.
Okay, we will comment this for this, and
we will add some description of the CRD, and maybe an example will be added there. Okay.
That sounds good.
Thank you.
Thank you.
Okay, so we're 5 minutes over time. Does anyone have any questions or comments, feedback before we finish? Okay, thank you, everyone. Bye-bye.